Welcome to our week 8 of lesson for the second quarter. This time we are going to talk about the percentage composition of compounds. Let us identify the most essential learning competency. Determine the percentage composition of a compound given its chemical formula and vice versa. And our learning objectives are: understand what is meant by percent composition, explain the procedure used to determine the percent composition of a compound, and calculate the percent composition by mass of the elements in different compounds. Let us just give you an idea of what a percentage is. So for example, on your last quiz, you got a score of 20 over 20. So this means that you got 20 items correct out of those 20 questions. Therefore, you got a grade of 100%. Percentage is also a useful tool in chemistry. The percent composition by mass represents the percent that each element in a compound contributes to the total mass of the compound. Study the chemical formula C12H22O11, or commonly identified as the table sugar. Based on this chemical formula, what information can we gather? So based on this formula, we can determine that there are 12 carbon atoms for every 22 hydrogen atoms and 11 oxygen atoms in the molecule of table sugar. So therefore, we can identify not only the elements but also the ratio of the components of that particular compound. And also, with this formula, we can identify the percentage composition. Percentage composition is defined as the percent by mass of each element in a compound. To compute for percentage composition, we need to know the molar mass of the elements. You can follow these 3 steps to solve for your percentage composition. So first off, identify or find the atomic weight or mass of each element involved in the compound. So again, you can get the atomic mass based on your periodic table. Second step, find the molar mass or the total mass of the compound by adding up the different masses of each element involved. And third, you can calculate the percentage composition by dividing the total mass of the component element by the total molar mass of the compound and then multiplying it by 100. Why do we need to multiply it by 100? Because it is the idea of our percentile. So the formula percent composition is equivalent to the mass of the component element divided by the total molar mass of the compound multiplied by 100 is our formula. We have here example problems to help us see it clearly on how we can compute for the percent composition. So we have here the chemical formula for table sugar. Based on our previous slide, we need to identify the molar mass first of the elements involved. So you are going to identify the molar mass of carbon, which is 12. So multiply it by the number of the atoms. So you have 12 multiplied by 12 would give you 144 grams per mole. Identifying the molar mass of the hydrogen, you have 22 multiplied by 1 would give you 22 grams per mole, and oxygen with an atomic mass of 16 will now be multiplied with 11 atoms. So you are now finished with step 1. For step 2, all you need to do is to add. You now have the total molar mass of the compound. We are now ready for step 3. Step 3 is identifying the percent composition. So this is our formula. Let us substitute our values. So that would give you 42.1%. For hydrogen, you have percent composition of hydrogen is equivalent to the mass of the hydrogen divided by the total mass of the sugar multiplied by 100. So you have 22 grams per mole divided by 342 grams per mole. So cancel out the units, multiplied it by 100, that would give you 6.4%. And for the oxygen, you have mass of oxygen divided by the mass of the sugar multiplied by 100 would give you 51.5%. To check if you have given or if you have solved or identified the correct percentage, you can add up all the percentages and they must total up to 100. So that means if it totals down to 100, your percent composition is correct. Another example that we have, you have sodium chloride or the table salt. Again, first step, identify the molar mass of the elements involved. Second step, identify the total molar mass of the compound. And third step, identifying the percent composition by dividing the mass of the element by the total molar mass of the compound. So you have percentage of sodium is equivalent to the mass of sodium divided by the mass of the salt. Multiply it by 100. You have 39.32%. The percent composition of chlorine would be 60.68%. Again, to check, add up the percentages, it must total up to 100. Our last example, percent composition of water. So step 1 is this. And then step 2, add. Step 3, compute for the percent composition. So after answering, you can use this or you can try your understanding and try to solve for this percentage composition of the following compounds. So you have sodium carbonate and sodium hydroxide. Take note that for sodium carbonate, you have sodium, carbon, and oxygen as the elements. And for sodium hydroxide, you have sodium, oxygen, and hydrogen. You can pause this video while you are solving or computing for your answers. And the answer to our activity is this. So you have, for the first compound, you have sodium. That makes up 43.40% of our compound. Carbon is equivalent to 11.32%. And oxygen is equivalent to 45.28%. On the right, you can see an example of a pie graph involving the different percentages of the elements involved. So in our pie graph, we just round it up to a whole number. So for sodium, you have 44. For carbon, you have 11%, and for oxygen, you have 45%. For number 2, you have your sodium hydroxide. So sodium percentage is 57.5, oxygen is 40%, and hydrogen is 2.5%. Again, an example of the pie chart is on the right. Just to clarify our performance task, you are to find a food label available in your house. So you can see this on the different food packages that you have. So analyze the elements with the highest percentage composition. So such as those encircled or highlighted on our video. You have sodium, calcium, iron, potassium as the elements. and based on their